Okay, this is booklet 10.4, speed time graphs for acceleration. There's two key things we're going to pull off of this idea, and that is it gives acceleration or it gives distance traveled depending upon what concept we're looking at. So the slope of the graph gives acceleration. So if we have a speed time graph that has a positive slope, that's a positive acceleration, meaning that the speed is increasing. So here the speed starting off at 0 and gradually getting larger and larger and larger until we reach a maximum speed right there. So if you can figure out slope, that'll give you the acceleration by how much the speed is changing. And similarly here, if I have a graph that looks like this, if it's a negative slope, that means negative acceleration, or the speed is decreasing. In this case, it's starting at a large positive number and gradually decreasing until the slope is at, until the speed is at 0, meaning that it's stopped. And of course here we have another example on the bottom of the page. Speed time, so gives acceleration as you can see in this calculation. And of course the slope calculation is equivalent to the acceleration equation, change in speed over change in t, same thing. So picking 2 points, figuring out y2 minus y1 over x2 minus x1, or in this case, change in v over change in t, speed and time. And this should be a review from your math class, where you figure out slope. We've seen this before on the previous sheet. Once again, slope is acceleration. Large slope, large acceleration. Small slope, small acceleration. No slope, because it's flat, means no acceleration. It's going at a constant speed, not speeding up, not slowing down, just staying the same. And a negative slope means negative acceleration, slowing down. The second point, so slope gives acceleration, area gives distance. So area underneath the curve will give you the information as to how far you go. And we keep it really easy in Science 10. We look at two different shapes, triangle and rectangle, just keep it simple. So here, if I was figuring out the distance traveled in this case, it's an increasing line. Figure out the area underneath, shade everything in below it up to 50 seconds. I would have to use the area of a triangle to figure that out, as you can see over here. Now you have some room on the bottom of the sheet. I'd like just to copy a little summary here, highlighting these points. So slope of a speed time graph gives acceleration. So if we look here, if I have a speed versus time graph, of course, slope from math class, it's change in rise over run, which is change in y over change in x, as you see in the green. And a change in y is second y minus first y. A change in x is second x minus first x, as you see over here. Now, the actual variables we have are speed and time, so change in speed over change in time. To figure out a change in speed, v2 minus v1 over t2 minus t1. So you can see how similar it is here. Once you know what the y and x variables are, it's really the same calculation. And the formula is the same as a slope calculation there, as you can see. Okay? And of course, area of a speed time graph gives distance. So key things: slope, acceleration, area, distance. And as I mentioned, we keep it easy. Two different types of shapes. If it's an increasing speed time graph, if you shade below that line, it's a triangle, so you use the area of a triangle. Area is half the base times the height, or in the case, half of time multiplied by however high the speed is here. So there's our time, and there's your speed that you use, the two values. If it's a constant speed graph, area of a rectangle, length times width, or in this case, time multiplied by speed. Okay, so copy out those will be very important and handy to use when you do the assignment on the next page. Take a quick look at the assignment. Number 1, how can you tell from a speed time table, so if it's a table of values like this, whether an object is accelerating, speeding up or slowing down? And then how can you tell from a speed time graph whether an object is accelerating. So I circled those words because reading those two questions quickly, they look like the same question, but one's referring to a data table, whereas the other one's referring to a graph. And then number 3, just a quick sketch, something that shows a high positive acceleration, something that shows a low negative acceleration. Once again, to figure out acceleration, you're looking at this. So make sure you sketch it indicating that. And then here, what I just talked about and what you just copied out, what feature on a speed time graph allows you to figure out acceleration? How do you figure out distance? So what are those 2 mathematical concepts that you use for that? Number 5 is a question involving 2 marathon runners. Their speed time graph is illustrated here. And then which runner has the greater acceleration? By looking at that graph, you should be able to tell me. And then it says also calculate it. So calculate the acceleration of the faster, actually of each of them to prove that the one that you think is going faster is going faster. And then which runner is ahead at the end of 100 seconds? So to do this, figure out the distance traveled for each of them. So for this person, and then for this person. So once again, the area. Figure out the area of this person, and then the area for that person, and you'll see how fast they're going. And if you subtract, you'll see how much further ahead that one person is. Number 6, question about a cheetah. Remember, cheetahs never win. Here is the data table over here, so you have to grab a piece of graph paper from the bin and graph that. You'll get a nice graph, looks similar to this. So it says, use a draw a speed time graph, then figure out the acceleration, and then figure out how far this cheetah has traveled at the end of 2 seconds. See? So if we take a look here,
the time has come that it's
right
paper recycling time. Please make sure all your paper recycling is outside your classroom. Thank you.
And I'll make sure my paper recycling is out. So we'll do that. Now I originally assigned this question, but I think I'm going to omit it because it's a fair amount of work as is. So don't worry about number 11, just simply cross it out. Just simply end off at 1 to 6. So questions 1 to 6 on this assignment, and you should be good.